So one important thing for you, I would say, is reading the textbook carefully. I have seen students who read the book carefully, they are able to do well in section A, and students who kind of were looking all around on the internet or using other books, they had a bit of trouble. So I strongly recommend everyone to read the textbook carefully. So that is the best way to learn this. There will be lectures, of course, but in order to get your concepts reinforced, you have to read the textbook. And if you see so far, so chapter 1, chapter 2, you should have read by this time. It's just, and also the problems at the end of the book. So reading inputs, all these things. Chapter 3 is on printf and scanf. Chapter 4 is on expressions. So by by this week, I would suggest all of you should read the first 5 chapters, including chapter 5. So first 5 chapters, at least first 4 chapters you should read for sure by this weekend. By this weekend, everyone should read the first 4 chapters. This is the reading assignment that I have for you. And please take time, read the problems. And there are questions on, can we use some other book like Let Us See? And so they are not good. Okay, they are all right, but they are not good. You can have them as references. This book is extremely well written. We did a lot of research in converging to this book. And I really recommend that all of you should read till chapter 4, including chapter 4. That is till page 65, you should read. And I presume that chapter 2 and chapter 3, they are for lab 3 homeworks. So chapter 4 and chapter 5 will be the next lab problems. And in fact, I will go ahead and say I will give three chapters. Chapter 3 in the next lab, chapter 3, chapter 4, and chapter 5 as problems for the coming lab. So there are many problems, I think in chapter 6, yeah, maybe. Anyway, so these 3 chapters, you should you should yeah, I should that they will be the problems for the upcoming week. All of you are given an access code to for the textbook, and you should I hope you got it right. I mean, Abhay is asking that how did you get the book? You all got the e-access code, right? Yeah. So if someone has a problem, send an email to me, and send an email to Jiawul, putting me in CC. Actually, we will resolve it. We'll resolve it. In order to access the textbook, you need a code. Everyone is provided, and the code for everyone is different. So it is mandatory to get a copy of this book, e-copy of the book. So good. So now, with this as the background, I would like to get started. We'll go slow in today's class uh, because try to understand where you are and how things are going. I know Jiaol did a fantastic job, but still try to connect with all of you and so that we'll be on the same page. So one thing that is let me get this thing right. Yeah. So yeah, so there is a problem that you would like to solve, real world problem you would like to solve. This is to give an overall view, real world problem that you have at your hand. Uh, Maybe I'll draw it here. So you have a real world problem. So this is the problem that you would like to solve. And like for example, this problem could be, for example, predicting how many COVID cases could be there in the next week, or you have the data about how COVID cases increased over the last 1 year, and you want to figure out like which states in which states the incidence is maximum, and so how, whether it is growing linearly or non-linearly, things like that you want to observe. That's an example of a one real world problem. Or you could be maintaining cricket statistics, or Premier League no football statistics, or you could be solving some climatology problem. So there are different real world problems, and so in order to solve these problems, the first thing we need to have is we need to come up with a representation of the problem. We need to come up with a representation of the problem, computational model or representation. So we need to have a computational model. So when we think of this computational model, so in order to solve this, so we need to have a computational. So computational model. So there is a computational model that we need to build for the problem. And when we have this computational model, there are two parts to it. That is, what is the storage structure or representation that we use? Representation structure. So one is representation structure. So there are two parts. One is representation structure, and second is once we have a representation of the problem, then we need to, like for example, in the case of COVID, how do you capture the data? How do you store the data and things like that? And then there are algorithms. We need to process this representation to elicit information from it. So here comes algorithms. Okay, This algorithmic thinking, all algorithms. So there is a data, and you apply. There is a data, or there is a model, uh, and you want to work on it. And it's not like these two are independent. When you want to represent something, come up with an appropriate representation structure for a real world problem, the representation structure, it is guided by what kind of things you would like to do on that representation. That is what kind of so while building this, you kind of take consider what kind of stuff you would like to do. And then these algorithms also depend on what is the representation that is being used. So this is a mutually independent thing. This is mutually independent. So, and then once we have this thing. Then we go to the next level. We use a certain programming language to, so use a, we write program or software for it. We write program slash software. What is software? It's a collection of programs, program or software for it. And here we use, like many programming languages, like we can use C, C++, like Java. There are so many high-level programming languages that are present, and you want to use these languages to capture. And again, it's a bit interesting. You will see later, or you learn later as you progress, that these two are not quite independent. To some extent, the kind of representation structure that you would like to come up with will have an impact on what programming language that you are using. Like, for example, you may want to consider some object-oriented design approach. So if you take object-oriented design approach to capture the problem at hand, to build a computational model of the problem at hand, then you may have to use a language which facilitates object-oriented design and programming. Like you may want to use C++, Java, etc. in that case. And then from here, you kind of, from here you go, this program or software, you generate assembly or machine code. And you rely on tools such as, like compilers here in order to map this software or program written into underlying machine code. The story doesn't end there because this machine code or this executable, it resides in the hard disk. And in order for it, so like like you have already seen programs, if you have written a hello.c program, so where does the hello.c program resides? Where does the hello.c program resides? You can answer in the chat box. Where does the hello.c program resides, for example? It resides on the hard disk, secondary storage. It resides on the secondary storage. It doesn't have a life of its own. It doesn't have a life of its own, right? So your hello.c, it resides on the hard disk. And you created this hello.c using some editor. So VS Code or VI editor or Vim editor, things like that. And what is the content of this hello.c? What will be content means, so what is the type of the data that is present in hello.c? What is the type of data present in hello.c? Strings. Okay, great. So let me, yeah. So if you go, this is my code. Let's go to this cd instructions text. Okay. Yeah. So this is cat pun.c. This is one program. This is one program pun.c. So this is a C program, right? Yes or no? This is a C program. So it contains sequence of characters. And these characters are ASCII characters. So because of that, if I see file pun.c, you will see it says the source, the pun.c file contains C source code and it contains ASCII text. So it's not an object file. It's not an object file. Pun.c is not an object file. Number one, it's a C program. And your processor doesn't understand this C program. It's not the language which the processor understands. and it contains instructions, as Siddiq said. But the thing is, these are the instructions which a C compiler understands, which GCC understands, but these instructions the processor doesn't understand. Are you all with me here? If there are any questions, please ask or put it in the chat box. So these instructions which your C compiler GCC understands, like what you intend to do, but your underlying processor doesn't understand. So what do we do? So we do GCC in order to, what do file pun.c do? File pun.c doesn't do anything. So file pun.c contains the instructions. It just contains a main function. So if you see Control O, yeah, so your pun.c doesn't contain anything. It contain the, what do file do means it, when you compile this, you are telling the C compiler that you want to print this string onto the screen. That is your intent behind this program. This is, you are specifying, you have a computational intent. You have a certain intent in mind, and that intent you are expressing using this particular programming language. That's all. You expressed your intent, and this intent you are writing, you are expressing your intent in this particular programming language, in C programming language, and the C compiler uh, understands this intent and then maps it into a form which your processor can understand. So now if you, so now you want to use this translator. So GCC, it's a compiler, it's a translator, it maps your high-level programming languages, high-level programs into a form which your processor can understand. So GCC pun minus O, uh, GCC pun.c minus O pun. So your GCC translates pun.c and executes what ultimately does the source code contain. So you're seeing now this is what your source code contains. Your source code contains the statements from your C, in this particular case, the statements from your C programming language. Yeah, each character is an ASCII representation. There are different ways of representing characters, but ASCII is one representation where every character is represented using 8 bits or 1 byte. So your C program is a sequence of ASCII characters. Or for that matter, if you see any text that you write in the editor, it's a sequence of ASCII characters. I hope you are with me. So your C program contains sequence of ASCII characters. Yeah, so this is the C program source text, which is translated into assembly by the compiler. So you see GCC pun.c minus open. So this is the executable that is generated. And where is this executable present? Where is this executable? Is the program executing now when you compile? Yeah, the program, the compiled program, if you do ls, the compiled program is present in the same directory. It's in the present on the hard disk. So if I see file pun, you can see it says no, it's an executable file and it has some properties, so on and so forth. So your pun is not present in the hard disk. It is not, sorry, it is present on the hard disk. It is not present in the same directory in the hard disk. It is not present in the RAM. It is not present in the main memory. It is not present in the main memory. And your pun contains, so did you do a disassembly of the object code? You did a disassembly of the object code, right? Did you use objdump? Okay, great. So you did a disassembly, right? So it contains the object code, machine code, which is ready for execution. So when I say dot pun, what happens when we give this command dot pun? It runs, it executes. Yes. So and it prints. So if you go back here to this our whiteboard and let's see, I just want to quickly recap these ideas. So you have this pun.c program, which is present on the hard disk, and you use GCC. So you use a compiler and compile this, and an executable will be generated. This is also present on the hard disk. And you use this command gcc pun.c -o. So when you generated the executable file is present on the hard disk. It's not active. It is like this, like for example, on your machine, the Chrome browser and many softwares are present. They are present just on your hard disk. They are not, when you want to execute your Chrome browser, you double click on that, Chrome browser, and the Chrome browser, the instructions of the Chrome browser program present on the hard disk will be loaded into the RAM. So this is your processor. So this is your CPU. This is your RAM or main memory. And so your CPU talks with the RAM, and the program fun.c from here, it will be loaded into the RAM, and it will start executing. So like for example, before you start the the class, the Zoom program is present, but it is not active, but you double click on the Zoom, then the Zoom program comes up. When the Zoom program comes up, what it means is the instructions of the Zoom program, which are present on the hard disk, they are loaded into the RAM. This is called as program loading. This is called as load processor. They are loaded into the RAM and your program starts running. So we are all on the same page till this point. This is the most important thing that you need to understand, that your source code is present on the hard disk. You compile it, the generated executable is present on the hard disk. And just because the executable is generated doesn't mean that it is running. You give the program for execution. When you give the program for execution, then the instructions of the program are loaded into the RAM, and and you start the program starts executing. Great. So this computational model, it is very interesting. Like for example, today we will see one problem, maybe that is you want to find the roots of the quadratic equation ax square plus bx plus c. You want to find the roots of this quadratic equation. How many roots it has? It has two roots, right? And so if you want to represent this this quadratic equation in the if you want to write a program to compute the roots of this quadratic equation, so what is the suitable computational model? How do you read? What do you read from the input, and what do you write? Yeah. So that's nice. So if you want to represent a suitable computational model for this is, you don't worry about no this x square x. All you do is you represent this this equation by just reading the coefficients ABC. This is an extremely simple example, because if you don't have that idea, what you will do is you will end up trying to read this expression ax square plus bx plus c from the input, and it will make a mess of your life. Are you with me here? That the model that we use, the computational model that we use to represent the quadratic equation, is we just store the coefficients of the quadratic equation, and that quadratic equation is represented inside our computer, right? So similarly, let's say you are working with an image. So if you are working with, or like for example, if you are working with a 2D XY image, we'll take a simpler example. So let's say if you are working with equations like this, 2x plus 3y is equal to 4, 5x plus 6y is equal to minus 3, and you want to write a program to find x and y which satisfies both these equations. So how do we represent these equations in the computer? What is the appropriate computational model for this? Yeah, so we have to use some notion of matrix. Like for example, so you have A11, A12, and let's call this as C1, A21, A22, let's call this as C2. So we have to, we would like to represent this in the form of a matrix. And when we would like to represent this in the form of a matrix, so this, so you have to use an underlying programming language feature called as 2D array, two-dimensional array, something like that, 2D. So you don't, this x, y, etc. They are not, they are not explicitly there, but they are implicitly there in your mental map. Are you with me here? So when you encounter a computational problem, the first question that you have to understand is, what is the suitable representation of this problem you in the computer is in your program is the first thing that you have to resolve. Are you with me on this question, on this idea? Okay, good. So now, with this as the background, let's see. So if you look at any basic computational process, I hope you're able to see the PDF. So if you look at any program, so let's take a big view and then we keep refining our view. Uh, uh, so if you take any program, so what we do is you read some input, and you compute or process that input, and you print that output, and you print whatever you have to print, and you end the program. So this is what is called as a flowchart representation for a program. So like for example, in flowcharts, we use this particular box, this parallelogram box. The color doesn't matter, but the parallelogram box indicates that the box corresponds to input. Similarly, this box indicates that that box corresponds to output. And then the square box or rectangular box indicates that we are doing some kind of computation. Any kind of program that we work with, it will have this structure. It reads input, we do some processing on the input, and we print output. Great. So in C programming language, for example, in order to read input, a whole bunch of many features are provided. So scanf is one thing which you have studied in detail. And scanf permits us to read input from the screen, and you'll also later learn that we can read input from files, so on and so forth. And similarly, the printf print output, you use the printf function that is provided in the C programming language to print output onto the screen or print output into a file. So lot of times C is a kind of a, yeah, it's a low level programming language. Because of that, there are many uh, details in scanf and many details in printf. But what I would like you to understand here is you should never miss out on the big picture, that at the end of the day you are using scanf to read input and you are using printf to print output. And mentally you should, and there are different nuances in using scanf and printf, and what they return and things like that. So these are all details, right? So when you get a doubt on these details, so what do you do? Okay, when you get a doubt on these details, so you just do man scanf and read textbook, or read the man page of scanf, and get an understanding about. No, so I have this particular doubt on how scanf responds. So you refer to the textbook or you read the man page, and you will get the answer. Similarly, you can look at the textbook or use man printf to see how printf works. I think yeah. So the point here is I don't want you to miss out on the big picture when you are writing these programs. What is the problem that is given to you? What is the input to the problem? What is the output to the problem? And how do you read the input? How do you process the input? And then how do you, print? How do you uh, report or print the computed output? And when you come to this process, this computer process input, so here broadly there are few things that you need to keep in mind. So number one, the representation of the input. So here when we think about the representation of input, so there are these primitive data types. So what data types you have to use to represent the input? Like for example, in the case of quadratic equation, what data type should we use? Char and int. Why do we need character? We can use int or float. Maybe float is more appropriate, right? There is nothing which says that the coefficient of a coefficients in a polynomial, they need to be integer, right? So primitive data types. So primitive data types, if you see, like for example, broadly speaking, if I have to draw some kind of picture, I'll just draw the picture here itself, so that, like if you see primitive data types, PDT stands for primitive data type, then broadly speaking, we can have, uh, integers. This is not, integer is not a primitive data type, but let's say we have integers or real numbers for the time. And actually, yeah, so let me redraw this. Integer is not a primitive data type. Let's say if in some problem you're working with integers, And if you are working with integers, what are the primitive data types that are available to you? So the primitive data types that are available to you are, like, for example, int is a primitive data type that is available to work with it, or long int is a primitive data type that is available for you. And within this int, you can have the classification. You can have signed int or unsigned int. Similarly, in the long int, you can have signed and unsigned long int. I don't know if there is long int. You just have to check. Is there a long int? Yeah, maybe check it. So I don't know. So these are the primitive data types. So, like, for example, you can consider a variable as signed integer or an unsigned integer. The default is a signed integer. Similarly, when you are working with real numbers, the primitive data type that is available is, the primitive data type that is available, one is float and other is double. And I don't know if there is something like long double. So I will explain the signed and unsigned int, etc. maybe a bit later. Don't worry about it. But for the time being, let's think it's one data type. So if you declare a variable as a signed integer, so that means it can hold negative and positive numbers. If you declare something as unsigned integer, then you can hold only positive numbers or non-negative numbers, because you can represent zero also. So like that, there are some primitive data types that your language provides, right? And then there is if you are working with text, then there is characters are also available. Okay, char is a data type. So when you want to work with text, then you can use char, and then using these primitive data types, you can have arrays of primitive data types. Arrays of primitive data types, and then you can have what are also called as structures, which you can come up with, and then you can define new data types. So we can from the primitive data types which are provided by the language, you can come up with new data types. You can come up with you can define your own data types. You can derive your own data types. All these ideas we will see in a while, but in this course, already you have seen some ideas. We will see more ideas as we proceed along the course. I'm just recapping or summarizing the ideas discussed so far. And then, so once you have the data, so there is data, so there is data, and on this data, you want to apply operators. You want to apply operators on this data. You want to apply operators like addition, multiplication, subtraction. So these are some operators, like uh, division, so on and so forth. So there are some operations that are applied. So when we think of these operators, so a couple of things we just need to be careful about. One is, like, for example, precedence, right? So I think you already studied. Did you study about precedence, operator precedence, right? So if you have something like a plus b star c, then no, this is something like this: a plus b star c, b and c. This is a tree, this is a tree representation of this expression, which says that multiply b and c first, and then whatever the result that you get, you add it up with a. Okay, so this is a precedence. And similarly, if you have something like, a plus b plus c, then you will have something like this. Let me, so that is, first add a and b, and then after that you add it to c. What is this property called as? What is this rule called as? Not associativity, it is left associativity. Because there are two possible ways. This is one possible way, and an alternate possible way for doing this is, like you do b plus c, and then you add a. So if you do the computation like what we are doing here, uh, then this is what is called as a right associativity. Right associativity. That is, we are doing the computation from right to left, but here we are doing from left to right. So this is left associative computation. So this is for addition, this is the rule that we apply in C programming language, for example. Are you with me here? This left associativity versus right associativity. When you get a doubt, you should draw this expression tree to get a clear picture. Nice. So now let's see this is precedence is operators and precedence is one thing. The second is typecasting. Second is typecasting. Like for example, if you have a plus fb, where f is a floating point number and it should be left associative. It's not like it should be. The C language semantics says it is left associative semantics. All right. So now if you have something like a plus fb, where a is an integer and fp is a floating point number. So if you draw an expression tree for this, you get a plus fp. But you know, in the underlying circuitry in your computer, it is not possible to add an integer with a floating point number, because the representation of integers and the representation of floating point numbers is completely different. So this particular thing you cannot do in the computer, not possible to evaluate this expression on your processor. So what do we do? So we take this thing and we kind of cast, okay, into two. We translate this tree into something like this, into to float, and and then you make this. This is a, and this is f. So what happens is, this integer a, it is not the underlying circuitry that cannot add an integer and a floating point number because the representations are different. So, but there is an operator called as int to float, which is not directly visible to you, but it is there underneath. So this a will be promoted to an integer, to a floating point number, and then that floating point number, floating point representation of a will be added with floating point representation of b to get the result, and the result will also be of type float. Are you with me here? Does it make sense? You're all with me? Doing good? Okay. So now, yeah. So there is, but this is the basic thing. So that's all you have. So you read input, you process input. When you are processing the input, how do you represent this input, and what operators you can apply on this data? And no, like what are the operator precedence rules, and how typecasting happens, and so these are the basic ideas. So Rishabh has this question: does the value will be stored as float permanently? No, because what happens technically, this is what happens. That's a good question. Let's say if you have something like c is equal to a plus fp. So this is what you see, but internally what happens is the compiler will do something like TFA. T stands for temporary. Uh, so int to float a, and then you will have c is equal to TFA plus fp. So because of that, the value of a is not changed. The value of a is converted into float and stored it in an in a different variable which is not visible to you. It's a compiler generated temporary. Does it make sense, Rishabh? Okay, good. Great. So now let's look at one more. If we use it like int is equal to float plus int, then yes, the float will be converted into int. That's true. So Namrat has this nice question. So if it is a is equal to b plus fc, b is an integer and fc is a float. So the generated float will be converted into into an integer. It will be typecasted back into an integer. I don't want to get into char at this point in time. We will look at the char at a different point. Yeah, there will be a data loss. You should be aware of that. That's true, very much true. Like for example, if you say if a is an integer and if you say a is equal to the result of this is 7.6, this 0.6 will be truncated and there will be a data loss. So when you are writing in program, you should know whether that data loss is permitted or not, because the compiler doesn't know whether it makes sense for you or not. It says this is my semantics and you use these semantics to write an appropriate program. In some cases it makes sense, like for example, let's say, like when you are representing an image, every pixel has a red, green and blue component. So in order to convert it into a gray pixel, gp stands for gray pixel, so you will have something like 0.8 times red pixel plus 0.4 times green pixel plus no maybe 0.5 times blue pixel, RGB, no? Yeah, blue pixel like this. So in this case, in the case of pixels, let's say the gray pixel value turns out to be 128.47. So dropping this 47 doesn't make any difference for you in terms of intensity of the gray pixel. But it can make a big difference if you are representing this 7.6 represents millions of dollars or millions of rupees, and if zero point 0.6 gets knocked off, then it's a huge loss for you. Are you with me on this example that in some cases it makes sense, in some other cases it doesn't make sense? You understood, right? Okay, great. Good question, very good question. So now let's look at some more examples. Yeah. Yeah, now let's take this example actually before we go there. So here, I know you have seen these programs, this kind of programs before, but for the sake of simplicity, let's do one more program. So like for example, in the case of if you want to compute the area of a square, you want to like for example, read the radius, and then you want to compute area. So you say area is equal to pi r square. So you have to use some approximation of pi and then you print area. So for the sake of simply just for the sake of completeness, let's write a program. It just takes a minute. So I'm just giving you a heads up. I will looking at the way speed at which we are going, we'll go till 11:30. I will give one complete cycle today, and then after that we'll break. We'll take half an hour more. I hope it is okay with you. 11:30 we will definitely conclude today's lecture. So Yeah, let's go here. Yeah. So this is the boilerplate code for us. That means it will be there. It's the standard code which will be present. We have a main and all that. So area.c. So the first thing is you scan input. So when you want to scan input, you want to prompt for the input. So you say enter the radius of the circle, something like this you have, and then you read the area of the circle. So sorry, you read the area, not area, the radius. So in it is possible for you to declare variables in the middle. This is permitted in what is called as a C99. How can we take irrational values like root 2? It is not possible to take irrational values like root 2 from the user. Yeah. So pi 3 point. Did you study about macros? A bit about macros, hash define, etc. Right? Good. Pi star radius star radius, and then you say printf area of a circle with radius percent 6.2f. Yes. So what does percent 6.2f do? Or just 0.2f will do? What will this do? What is this? There are some people are saying no, and some people are saying yes. So what the compiler does is it just replaces pi with 3.14. Yeah, good. So radius and area. Good. So here, so this pi, this hash defined pi 3.14, this is handled by what is called as a C preprocessor. It is not a global variable. Pi is not a global variable, guys. So this will be wherever pi is present, it will be replaced, textually replaced with 3.14. Okay, there are few questions. Number one, pi is not a global variable. And so this is like for modularity, because when you are writing big programs, like if you are using pi in 10 different places, then if you decide later to use a different approximation of pi, then going and changing pi at every place, you may miss it out. Does it make sense? Like, for example, you are writing a program. One place you are computing perimeter, at another place you are computing area, or some other place you are computing something else. So if you if you decided to use a different approximation for pi, you have to go and change all those things, and that is a problem. So having it this way, like for example, you can have something like float. This is what I'm talking about. Float circumference. is equal to 2 star pi star. So here what main is a function which is in the main we are not returning anything. So it's a main is a special kind of function we will see later. But for the time being, you can just put void before main and it should be good. So this is a straight line sequence of code. This is a straight line sequence of code in which you are reading the input here. So read input here. And you are processing the input here. Process input. And then you print output. So this is what happens in all programs pretty much. What does 6 do in person 6.2f? No, pi is not a keyword. Pi is not a keyword. Pi is a macro variable. Pi is what is called as a user-defined macro. This is what is called as a macro. So for the time being, don't worry about. No, there are few things. I want you to. This is where I want you to take a step back. And most of the time you will get lost in the details of what does 6.2f means. So you just have to look at the textbook and know it's so probably 6 means I also forgot. I taught it last few weeks back, but I still forgot what that 6 means. But we will. But I hope that Jiao would have taught it. I'm sure. But you can look up at the textbook, and some of your friends are saying 6 digits will be printed, minimum of 6 digits.
That is used for indentation, left indentation.
The left indentation.
Of the
left or right, Jiao?
So the point 6, the 6 number is used for.
It's not left, right? It is right.
Yeah, it's right indentation or left. Some indentation, sir. I forgot.
Yeah, some indentation. Yeah, it's right indentation. It's not left.
Yeah, it's
minus
right.
6 means left. Yeah, that's true. So it's yeah. So it is something. So let's not don't get. So you kind of miss the big no. You miss the forest for the trees, or as they say. So I want you to see the big picture, because this computational thinking you have to develop. Right? So what is percent 6.2f? What is percent 2f? It's they are there. They will be clarified. You can read the textbook, but this big picture we would like to get.
Sir, one more, sir. I have not covered macros actually. I missed macros.
Oh, is it? No problem.
Yeah.
I'm not expecting, but that's the reason I asked.
Okay.
So macro is we will see macro is very simple. Wherever pi is there, so wherever pi is there, they were taught in the lab. Okay, good. That pi will be replaced with that 3.147. Are you all with me so far here? Does it make sense? You're doing good, right? So what do we do? So now so GCC area.c, enter the radius 2.2. So it is the area of a circle with radius 2.0 is 15.23. I should put a slash in here. New line character. Good. Just main means int void. Int main, not void main. So before GCC, yeah, so there is, we will talk about macros later, because I want to cover some ideas, important ideas in today's lecture. We will revisit macros one more time, but I am making a note on revisit macros. Okay, so now let's yeah, I don't want to take questions on what is the difference between int main and void main, etc. Hold on to those questions. Okay, hold on to those questions. For the time being, see what is the flow of the computational structure. All right. So hold on to them. They are details actually. Those details we will take care of them. They will take care of those details. They are not very, big things. So easy to understand, but they take our attention away from the main ideas. So now let's take a look at I'll talk about unsigned and signed also, not now, just focus on the ideas that I'm discussing in today's class. So let's say you have this this is a flowchart for a different program. So here we are reading the income. So here you can see, so we are reading the input here. You read income and you read cost. You check if income is greater than the cost, that is expenditure. And if it is the case, then you got profit. You compute the profit, income minus cost, and you print the profit. On the contrary, if income is less than the cost, then you compute the loss and you have to print the loss. And you come to that. In the code that you have seen so far, so one instruction gets executed, and then after that, the next instruction gets executed. After that, the next instruction gets executed, so on and so forth. This is what is happening. This is what is called as a straight line sequence of code. But now we are seeing a code where, depending on some condition, either you have to execute some set of statements or another set of statements. So how do we go about coding this program? So in order to code this program, we have to use what is called as an if construct. We have to use what is called as an if then else construct. Yeah. I just want both these things to be together, but let's see. Yeah, great. Just give me a moment. I'm setting these things up for myself. Great. So now we are in. So now we are writing a new program, which contains, which is the first thing. So here again you have the same boilerplate code. Hash include stdio dot h main. So float income and cost. So two variables. Let's store the program. Profit account.c accounts.c. So we have, so and then you say printf your income So you say this is your income, and then what is your costs? and then you check if income is greater than or equal to. So here there are two lines of control. If income is greater than or equal to cost, then you execute some set of statements. Those set of statements, you put them in these two what are called as flower brackets. On the contrary, if income is less than costs, then you execute the code that is present in the else part. Ah. Great. So here, so what do you do? So you kind of now you have something like a float profit. Actually, you may not even want to. You can just say printf profit %d%f /n income minus costs. And then you say loss cost. So here what happens is the condition on line 12 will be evaluated greater than, if income is greater than or equal to costs, then you execute the statement on line 13, and after that you come to the end of the program. Like for example, you can have a statement like printf accounting done. And then if loss, if it's the loss, then no, you go to, if income is less than cost, you go to the else part. Are you all with me here? Does it make sense, this program? So GCC, so accounts.c. So yeah, in order to get over this thing, we can just have void for the time being. Your income is 12.3, whatever that means, 32.0. So you will say, no, this is the loss. But let's say if the income is 32.0, but if the costs are 12.3, then you will have a profit. You all understood the program? You're all with me here? Good, right? Are you all happy? Doing good? You understood the program? What is the one? That is the difference. Yeah, don't worry. We will revisit it. We will think about it. It's a good question, good observation. We will visit it later, why it is like that. Okay, good question. Good question here. But now, such a simple program, you made a huge conceptual leap. You made a huge conceptual leap. So now what we want to do is, I will show you one more flowchart, and that will be the culmination of today's lecture. And yeah. So here you are able to see this flowchart, right? Okay, great. So here you start the computation. So earlier what happened is, so there is an if condition. Sorry, so let's see. So there is a condition. Usually this is what, so let me actually pick that diagram. Yeah. So this is the thing that we did now. So there is a decision. Based on the decision, either you go left or you go right. It's actually a better picture for what we did before. Uh, is this is what we did. Okay, so we started before for that, and then so we read that input, no, whether income and costs we have read, and then we did we asked a question. The question is whether income is greater than uh, costs or not. And then based on that, we executed something here. Based on that, we executed something here. And then after that, we have reached a chunk of code here. And then finally, we ended. So bad drawing, but so here we read the income and cost, read income and cost here. We check if income is greater than cost or not. And so one path is a loss path and another path is a profit path. And then finally, we both the controls, they converged here. And this is where we said, no, the whole accounting is done. This is the flowchart picture for what we did before. But now, so we are doing something else right now. So here, what is this? Like you want to take a decision, and depending upon the decision, uh, so if it is yes, then you go ahead and do something. Otherwise, we loop back. So for example, in order to weight does this, this will be useful to you. Like for example, the place where it will be useful to you could be you earlier, if you take our simple, extremely simple program, uh, or extremely simple program, let's take this program, area.c, right? So now I don't want to compute just the area of one program, of one circle. I want to see if I want to keep asking the user, do you want to compute the area of one more circle? And the user picks no, 1 or 0. 1 means yes, 0 means no. Then and then based on that, I would like to continue or not. So here, so this is what we would like to do. So here printf. Uh, so you do the one cycle of computation you do. So and then here you want to ask this question, printf. You want to ask this question: Do you want to compute the area of one more circle? This is the question you ask, right? And then the user has to answer 0 or 1. I'm just using 0 or 1 for the sake of simplicity. And then we use a simple flag variable, int flag, and then we will say, so scanf %d ampersand flag. And then we will say, if flag is equal to 1, then we use what is called as a GOTO statement. GOTO statement, yeah, so let me use L1. Okay, L1 means it's the name of a, yeah, so here, so I have this thing L1. So this is fantastic, guys. So we are making a big progress leap in what you can do here. So you, from line 11 to line 19, line 11 to line 17, we are doing this computation. Okay, what we are reading the radius of a circle, we are computing the area of a circle, and we are printing it. Yeah. So we don't worry about circumference for the time being. This is what we are doing. But on line 20, on line 18, we are asking the question, hey, you want to compute the area of one more. So there is this nice question, don't we need flower brackets? So we will come to that later. But for the time being, let's use flower brackets, no problem. We don't need it if there is only one statement, but for one-liners, we don't need it here. So if flag is equal to 1, then you go back to line statement 10 and then you repeat. Are you all with me on this program? You understand the semantics of GOTO? GOTO means go to the C language statement which is attached to the label L1. So now let's compile. It can be bool. So the type. So let's not worry about the type right now. So GCC label.c dot a dot out. Enter the radius of a circle 12.3, and then it asks the question: do you want to compute the area of one more circle? So you'll say 1, and it will say 13.4. It computes the area of the next circle, and if you want to come out, you press 0. You come out of the program. So what is the power of computers? The power of computers, there is no end statement for L1 bracket, etc. You just go to jump to statement which is labeled L1 and you forget. So nothing like that. So that's it. There is no end or anything like that. Are you all with me on this program? How many of you are with me in this program? You understand what is happening here on line 21? You use go to L1, you go to statement which is labeled L1, and that's it. So this is the fantastic thing, because the power of computers come in their ability to repeatedly do the computation on the same kind of computation on different data again and again and again. Like for example, you have a file which consists of the radius of million different circles. So you should be able to iterate and uh, so else is not required. Good question. So here you don't need else. So we have if statement with else, without else. In this case, there is no else required. So we have looked at if statement. We have looked at if then else statement also. No, it's but this is fine. What we have, the labeling way we did, it's all right. So yeah, so now this is the 7th lecture, and you can go ahead and write any program that you can, using the constructs that you have seen now. Any program you can write using the constructs that you have seen now. You are fully empowered. So this is a major milestone in your programming course, because there are many other details. Okay, let's not worry about those details. We will come to from a computational thinking perspective, the key things that are required for you, they are there available for you. Double equal to here is on line 20. We are using double equal to. That means it compares whether flag is equal to 1 or not. That is a comparison operator. I'm sorry, some things I just assumed, but yeah, this is a comparison operator. Are you all with me? This is the right place to, what if flag is equal to 2? Then what happens is nothing, you come out of the code. Only if flag is equal to 1, then you continue, but otherwise you just come out of you don't go to statement 21, you come here. If flag is equal to 2, you come to statement 23 and your program terminates. So if you're all happy with the discussion so far, this is the right place to stop. Believe me, this is a major milestone, because pretty much no, you're all on you're all very good. You can write many powerful programs using the constructs that we have seen. And going further, we will look at more language things which will make your life much more easier. All right. So shall we conclude today's lecture? You're all good? Happy with today's lecture? Okay. Good. So we will catch up. So we will catch up and we will do more fun stuff as we keep going further. I don't want you to no. So stay interested. We will solve interesting problems and so those of you who did chapter 2 and 3, start with chapter 4 and start working. Everything else is a detail, guess. This is the core of the whole stuff that we are of programming, what we have seen. Okay, that's all I have for you today. Bye, and I'll catch up with you on Thursday. Yeah. Bye. Yeah, please go ahead and start with chapters 4 and 5, and yeah, that's the plan. Okay.